Is a trip to Venus a breeze? Far from that. Venus is a super hot planet. The pressure over there is very high. The atmosphere is very corrosive, is very acidic, and the density of the atmosphere is very high. So it's a tricky place to go. 30 years ago, Soviet Union sent Venera 13 to Venus, and it lasts only about 2 hours before it gets toasted. And after 30 years, the problem is still there. There are a lot of proposals that how we can go there and how we can last longer over there. And most of the ideas are about putting all the scientific instrument within a chamber, and you're gonna provide it some cooling so it's gonna last longer. And we need some sort of mobility over there. And when it comes to mobility, most of the ideas are about using an airship. Assume that we have our cold bay in the middle, and around we have an envelope. In between, we have a free space. The simplest thing comes to mind for making this system mobile is to insert some sort of lifting gas like helium inside that free space. But it definitely provides the mobility, but there is a problem. That gas starts to circulate the heat over there, so it becomes super hot and the game is over. But how about the idea if we replace that lifting gas with some sort of spare solid, which I'm going to call it buoyant architected materials or BAM. There is only one category of the material that can make the idea of the BAM possible, and that's ceramic materials. And they have a unique feature. Their strength is pressure sensitive. What does it mean? Assume that we have an athlete which is physically very big. When he lifts the weight, he's not experiencing much pressure. Right now, assume that I stop feeding this guy. So he shrink, he become very slender. Right now, if you want to lift that weight, you're gonna experience a lot of pressure. Most of the humans and most of the materials do not like high pressure situation. But ceramic materials enjoy high pressure situation. They become stronger. In my research, I do a lot of mathematics, optimization, and finite element modeling to develop designs that exploit these unique properties of the ceramic materials. At the end of the day, I'm gonna have the designs for the BAM that is ultra strong, that can withstand the crushing pressure of the atmosphere. It is ultra lightweight that can lift the vacuum airship and provide us the buoyancy, and it's a super thermal insulator. So we shouldn't be worried about the effect of high temperature on our scientific devices. And it helps us to last on Venus forever. Thank you so much for your attention.